Hello, good morning. Peak area and proton coupling. The relative peak areas indicate the number of hydrogen atoms in a particular environment. The relative peak areas indicate the number of hydrogen atoms in a particular environment. Coupling arises because the magnetic field of vicinal or adjacent protons influence the field of that proton experience. Coupling arises because the magnetic field of vicinal or adjacent protons influence the field of that the proton experience. Significance of peak area. Peaks obtained in the PMR spectrum make different areas with the baseline. Peaks obtained in the PMR spectrum make different areas with the baseline. It is observed that area under a PMR signals is directly proportional to number of equivalent protons giving rise that signals. It is observed that under the PMR signals is directly proportional to number of equivalent protons giving rise to that signals. By comparing the areas subtended by different signals, we can calculate the relative proportion of different types of protons. For example, in case of peaks of benzyl alcohol, the areas under the peaks are in the ratio 1:2:5. We have already discussed in the above question, indicating that the three types of protons are in the ratio 1:2:5. This is actually so. One types of hydrogen. This is another one types of hydrogen. These are the five another ones of types of hydrogen. So there are one hydroxyl proton, two methylene protons, five ring protons. The peak areas of different signals are measured by an automatic electronic integrator. Also, height of peaks are proportional to areas. How can you explain the difference in chemical shifts of aromatic protons in the flowing compounds? Benzene delta equal to 7.37, toluene delta 7.17, paraxylene delta 7.05, benzene, toluene, and paraxylene. Methyl group is an electron releasing group, hence in toluene, the effect of methyl group will be to increase electron density around the ring protons. Thus, the protons will be shielded and they will absorb uphill. Therefore, toluene gives a chemical shift slightly uphill at delta 7.15. Thus, the proton will be shielded, they will absorb uphill. Methyl proton in an electron releasing group, hence toluene, the effect of methyl group will be increased electron density around the ring protons. Thus, the protons will be shielded and they will absorb uphill. Therefore, toluene gives a chemical shift slightly uphill at delta 7.13. In xylene, the effect of two methyl groups in compounded making ring protons still more shielded. Thus, paraxylene will absorb still more uphill delta 7.05. How can PMR spectroscopy be employed in differentiating between the ethane, ethylene, and acetylene? All protons in ethane, ethylene, and acetylene separately are equivalent, hence we expect only one signal is in the above compounds. However, the environments of protons in ethane, ethylene, and acetylene are different. Hence, absorption signals will be obtained at different positions. We can know the chemical shift in the three compounds by consulting the table of chemical shift. These are given below. Methane 0.9, ethane 0.9, ethene 5.3, ethine 2. How many signals do you expect to have in NMR spectrum of chloroethane? What would be the approximate absorption position of the signals? Chloroethane ethyl chloride has two types of protons, three equivalent methyl protons and two equivalent methyl protons. Hence, we expect two signals. Methylene protons are attracted to carbon, which are also an electron withdrawing chlorine attached to it. Thus, the electron withdrawing or shielding effect of chlorine will be more on methylene protons than on the methyl proton. So, methylic protons will absorb downfield compared to methyl protons. The signals are obtained as below. Methyl protons delta 1 to 1.5, methylene protons 3.5. Okay, it's all about peak area and proton coupling and significance of peak area with related problem solving. Thanks for watching and request you all like, comment, share and subscribe. Thank you for patience. That's now bye-bye.